8M2, lesson 9, sequencing rotations. This should be a lesson that's a little shorter like last lesson. I'm going to mostly assume that you know how to do rotations. You should know how to do those. Those were taught in a previous lesson. And we will use our tool GeoGebra, which we'll be using perhaps just a couple more lessons. But I think it really highlights, it makes it really quick to see how how you can sequence rotations, and that if you sequence rotations, that it depends on what order you're going to do your rotations in as to where your final object will end up, and I will demonstrate that to you. And again, the tool GeoGebra makes that pretty clear. And I encourage you, well, first of all, let's just cut over to the screen. And I just want to start with two things. And I just kind of told them to you. But first of all, I want to make sure that you, I assume that you know how to perform rotations by using a transparency. And secondly, hopefully you are familiarizing yourself with GeoGebra.com so that you know indeed how to play with translations and reflections and rotations and combining them. And if not, maybe you can copy what I do through this video and see for yourself how you can use this tool to maybe even help you with your homework, but to also really quickly see that translations, rotations, and reflections, one, how they work, and that the order matters when you perform these operations. Okay, so again, that's what I assume you know. Now what we're going to do is I want to demonstrate you the key to this lesson, and the key to this lesson is basically, this is the whole key. The key to lesson 9, or the key learning, the key learning is that when sequencing rotations, and all sequencing rotations means, and I'll define that for you in a second. When we're sequencing rotations, the order of your rotations matters. The order matters. And sequencing basically means, let's define this word, sequencing rotations, performing 2 or more rotations in order on an object. Okay, that's what sequencing rotations means. And if I were to take an object and rotate it around one point and then around another point, it often, or 99.9% of the time, will be different than if I if I rotate it around the second object or second point and then around the first point. Okay, that's the key learning. Now let's see it in action. Okay, what I have done here is I am taking a triangle and I am going to first rotate it by a certain number of degrees around point D. As you can see, right? I'm rotating, in this case, I'm going to rotate this triangle around point D. And then after I rotate it around point D, let's just try and get that right at 180. And then I'm going to rotate it around point E. So notice, I take my second thing and I'm rotating it around point E, which is right down here. Right? I first rotated around D. This is halfway around point D. Now I'm rotating it around point E, and you can see how E becomes the center. And if you were to use a transparency to perform this rotation, you would see the exact same thing. Right? This would be halfway around point E, 180 degrees. So let's just do it 180 degrees around point D, and then 90 degrees around, well, 90 degrees around point E. So this is one rotation and 2 rotations. Now what I'm going to do is I'm going to rotate it instead of 180 around point D and then 190 around point E, I'm going to go 90 around point E. I'm going to take the object and go 90 degrees around point E. And then 180 degrees around point D. Boom, it's off the map. Off the map. Okay, so in one case, again, rotate first around D, then around E. In the second case, I'm rotating around E and D. And notice that they're in opposite places. And we can play this game a couple different ways. So let's move our points to different places and see how this manifests. Let's just say I'm going to rotate around point D, and I'm going to put point D right. Let me put it right here. I'll put it up. Let's say I put it right here, and I'll put point E right over here. And we're going to see the same thing. And let's just pick a number of degrees. Let's do 10 degrees and 10 degrees. Let's go 10 degrees around, or 10 degrees around each one. So first of all, we're going to go 10 degrees around point D. Now let's do 20 just to make it change a little bit. 20. How about 30? You know what? I'm going to change this thing so that it increments only by 5, as it'll make it easier. We'll do each one of these by 5, so it won't be as hard for me to get exactly where I want it to go. Make that by 5. 5. Sorry, I should have set this up right off the bat. Should have set it up right off the bat, but we'll get it going right now. Neat thing is you can watch my mistakes, and you can, as you do this on your own, you can just fast forward right past. Okay, so now we're going to go 30 degrees around point D, and then 30 degrees around point E. So that's 130 around D and then 30 around E. Now I'm going to do 30 around E and then 30 around D. And you'll see they're different. And that's kind of a mess. Why don't we do, in the first case, let's choose some different numbers that show a bigger difference. Let's choose, how about 70? See how this goes right around point D? We'll go 70 around point D. And then 70 around point E. This one's just going to spin right around point E. Watch this. Watch this rotation. That's 70 degrees because we're so close to it, it doesn't move very much. It just spins. Now we're going to do 70 around point E. That's around, point E. And now we're going to rotate it around point D. And notice how we're very, very different. Again, this was our second triangle, this pink one. And in the second case, our second triangle was, or our doubly rotated triangle is this blue triangle. All right, so what if we did, what if we did 90 and 90? So we'll do 90 degrees first around point D, and then 90 degrees around point E, and that's the second one's just spinning. And now we're going to do 90 around point D, and then 90 around point E, or D. Okay, so I just wanted to show you a number of different rotations, pairs of rotations. Again, the whole key to this lesson is that order matters. And what you did today in class is they just had you rotating over and over again using transparencies to twist objects around various points. And if you twist it around one point and then around the second point, you're going to get a different answer than the second point around the first point. Now what I want to do is I want to quickly cut to some homework help. And I'm going to come back over to the sketch pad and give you your homework help because uh-oh, what's going on here? Let's go back. Let's see if I can open up that first. Something's going on. All right, let me create a new window. Something's going on. My saved, don't save. Background. Oh my goodness. Let me just refresh this screen here. Okay, so this is going to be, let's go back. We're on 8M2. Wow, I have to reset everything, even my pencil width. 8M2, lesson 9, sequencing rotations. And this is homework helper. So the first key is remember, everything, the homework is done using transparencies. Probably. That's probably the easiest way. If your teacher lets you use GeoGebra, then that's another way to do it. Number 2, remember, rotations preserve. Let's go all the way back to lesson, 2, 3, 4. Rotations preserve A, angles, B, line segments, so let me just go back to GeoGebra real quick. Notice that when I took my original triangle ABC and I rotated it once and I rotated it again, I ended up with this blue triangle and this pink triangle. Notice my angles, I still have my right angle. I still have a right angle and I still have my other 2 angles, and those angles are going to be the same size no matter how many times I twist them or move them. Similarly, the line segments are the same length. It doesn't matter after I rotate them once and rotate them a second time. Notice BC is still the same length as B prime C prime, and that is the same length as, GH. The line segments are preserved. So if I could rotate once, twice, 3, or 100 times, this object is still a rigid object. So remember that. So rotations preserve angles and line segments. I think there's a question about that as well. And 3, the order of rotations matters. If I take triangle ABC and I rotate about, 90 degrees about point A, and then 180 degrees about point B, that is different than rotate 180 degrees about point B, then 90 degrees about point A. And just because we haven't done it recently, let's put down a happy cat, because that we've learned a few key things. Hopefully this was a useful lesson. I know it's a little bit different. We don't work a lot of problems. It's a little bit more demonstration. But hopefully these tools that I am offering you and some of the demonstrations that we've done are useful to you and insightful for you. And hopefully the homework helper is helping you at least get through some of the homework. Hopefully this rotation, reflection, and translation stuff isn't that hard. And if it is, send me an email or leave me a message on YouTube, and I will respond to it, and we can do some other videos. Hopefully you enjoyed this, and we'll be seeing you thank you. We'll be doing lesson 10 tomorrow.